Hi everyone and welcome to this video. In this video I'm going to be going through this GCSE foundation paper. This is the paper 1. This is a past practice paper, but if you can go through as many of these practice papers as you can before your exam, if that's your best case scenario, I'm going to be going through all the steps I would take, how they're going to mark it for you. And please let me know in the comments if you have any questions or any other ones you'd like me to have a look at. So let's get straight into it. So this is an uncalculated paper, and generally in these ones they start off with these easy 1-mark questions. You shouldn't be spending more than a minute on these. You just put down what you know and move on. So write 0.9 as a fraction. So with fractions like this, let's zoom in a bit here. Sorry about that. With fractions like this, what you do is you look at the number of decimal places that you have. So if you have one decimal place, like here we put 0.9, one decimal place means that it is over 10, and it's as simple as that. So this is just going to be 9 over 10. And then just so you know, if it was 2 decimal places, then it would be over 100. So if you had 0.99, for example, you would write that as 99 over 100. And so on. If you had 3 decimal places, 999, you'd write that as 999 over 1,000. So the number of decimal places tells you how many zeros you've got at the bottom. So this is 1 decimal place, so I've got the 1 0 there, so 9 over 10. Question 2, change 45 centimeters into millimeters. These are all these units that you have to know how to convert between. So you have to know if you've got centimeters and millimeters. If I'm going from centimeters to millimeters, I'm timesing it by 10. If I'm going the other way, I'm dividing it by 10. And so we go 45 centimeters to millimeters. That means I'm timesing it by 10. And 45 times 10, we just add a 0, so 450 millimeters. 3, simplify that, so 5 times a times 2. When you're simplifying an algebraic expression like this, it's as simple as just you multiply the numbers, so 5 times 2 is 10, and you just list all the letters after each other, so A. Question 4, work out 1/6 of 300. And again, keeping in mind we don't have a calculator. For a question like this, I usually rewrite it. So I would say 1/6 of means times. I would always just do that. 1/6 times 300 over 1. And then we can just multiply the fractions. I'll show you 2 methods to do this one. So we would go top times top. So 1 times 300 is 300 on the top. Bottom is 6 times 1, so 6 on the bottom. And then this is 300 divided by 6, which you can do your method for. So how many times does 6 go into 3? It doesn't. How many times does 6 go into 30? So 30 divided by 6 is 5. And then how many times does 6 go into 0? 0. And so we are left with 50. And so 1/6 of 300 is 50. So that would be the one way of doing this. I'll show you another way of doing it if I've got some space here. The other way is if they ask you 1/6 of 300, you can always rewrite this as 300 divided by the bottom number, so divided by 6 times by the top number. And you'll see 300 divided by 6 is 50, 50 times 1 is 50. So either method there that works for you. Question 5. 30 children were asked which sport they wanted to play. Here are the results, and they want us to fill in the frequency table. So if you see a question like this, it's really great because these are some easy marks here. All we're going to do is we are going to fill this table in. We just we're going to put tally marks and we're going to put the total number. So let's go through. I would cross these out as I went. So football, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 footballers. So you put the 10 in the frequency, and in the tally you're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go on to cricket next. So we got 1, 2, 3, 4, 5 cricketers. So 1, 2, 3, 4, 5 cricketers, and we write the number in the frequency. And we just go through all the others like this. Netball, we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And finally, we've got rounders 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. So nice, easy 2 marks for that. And then usually the next step would be draw a bar chart to show these results. So again, a bar chart is 3 marks. It's pretty straightforward. There's just some rules you have to remember. So we always want, let's get the pen. We always want the frequency in this column and then the categories in the bottom. So sports on the bottom. It's a bar chart. What they're testing is, do you know you have to leave a gap between each of them? The frequency, we can just label it 0, 1, all the way to 10. And then our sports, we're going to leave a gap. And then football, rounders, netball, and cricket. So you can see this is 3 marks. This is already 1 mark just for setting this up like this. Then if we draw them in, you'll have to excuse my drawing. Don't have a ruler on here, but football, we've got 10 footballers. And so we're going to mark it up to this 10 here. And then draw it all the way down. Rounders, we had 9. Netball, 6. And cricket, 5. Okay. And so, like I said, you're going to get a shape for having the correct columns. You have a frequency on your left, your categories on the bottom. You're going to have a mark for making sure it is a bar chart. You've got gaps, and then for your general shape. So you've got the right numbers listed here. Question 6. Plot the point with coordinates 2, 3. Label it point A. Okay, so whenever we have coordinates, we need to remember it's always the x point first and then the y point. So if we have the coordinates 2, 3, we're going to go to where is x2? So x is 2 here. And 3. Y is 3. So 1, 2, 3. There we go. That is our point A. X is 2. Y is 3. Write down the coordinates of the midpoint of BC. So the midpoint just means what is the middle of that line, BC. There are two methods, so you can just, in this case, we can just read off the midpoint. So we can see that there is halfway. So that is when x is 0 and y is 1. And then I'm also just going to show you a method just so we, in case it's not as easy to read off here. Okay, so the midpoint formula, what you do is you take the x coordinate of b, you add the x coordinate of c, and you divide it by 2. So you just take the 2 points on the end of the line, the y coordinate of b, the y coordinate of c, and you divide it by 2. So if we have a look here, point B is the x is -1, the y is 3, and point C, x is 1, y is -1. So if we then work these out, xb is -1, we add on xc, which is 1, and we divide it by 2. That is going to be -1, add 1 is 0, divided by 2 is 0. So we see we get that same answer there. If we look at the y values, we're going to go yb is 3 plus yc is, that's -1, divided by 2. So 3 plus minus, that just becomes a minus. 3 minus 2 is 2. 2 divided by 2 is 1. So we can see we get that same answer. So in this case, all you have to do is just read off that midpoint. What is the middle of that line? But I'm just showing the formula in case it's not such a simple one. You can't read off the value. And then finally, draw the line with the equation y equals -3. So if we look at this one, so y is this axis here, and here y is equal to -3. And it's equal to -3 here, and so on. So if we want to draw that line, we just connect all these points. Sorry, excuse my drawing again. I don't have the ruler, and you label it y is equal to -3. Question 7 is an angles question. So they tell us this part is x, that part is 85 degrees. Find the value of x. So you need to know that angles around a point add up to 360 degrees. So that is actually going to be our reason here. And so if we have 360 degrees, we can take away that 85, and then we get x. We don't have a calculator, so let's just do it properly. 360 take away 85. So 0 take away 5 we can't do. So we're going to cancel the 6, make it a 5. And then 10 take away 5 is 5. 5 take away 8 we can't do. So we're going to cancel this 3, make it a 2. And that becomes 15 take away 8, which is 7. And 2 take away nothing is 2. So x is going to be 275 degrees. Which checks out. We can see that this is a really big angle. So that is 275 degrees. Question 8. A total of 1,400 tickets were on sale for a show. 819 of the tickets were sold. How many tickets were not sold? They're just testing. Can you figure out a word problem, what they're asking? And can you do the subtraction? So here we've got 1,400 tickets to start with. And then we sell 819 of them. How many are left? So 0 take away 9 we can't do. We can't borrow from there, we have to borrow from the 4. So that becomes 3, we've got 10. Cancel that, that becomes 9. 10 take away 9 is 1. 9 take away 1 is 8. 3 take away 8 we can't do, so we're going to borrow again. 13 take away 8 is 5. And so we've got 581 tickets. So you get a mark here for this one for your final answer, and you'll get a mark for knowing that it's a subtraction question, even if you don't get the answer right. That's why it's really important to make sure you're writing down what steps to take, so they can give you a mark because they can see you did know you had to subtract, even if you got the answer wrong. Question 9. We on algebra now. This is what we call a substitution question. So if you're struggling with this, that's what you need to look at. We've got this equation. Work out the value of A when B is 6 and C is 2. These ones are really straightforward. So if you get this one, you're going to be really thankful. So we've got A is equal to 3B minus 2C. And all they want us to do is sub in these values. So A is equal to 3. Wherever there's B, we're going to put the 6 minus 2, and C is 2. Then we just work these parts out. So 3 times 6 is 18. 2 times 2 is 4. So we've got A is 18, take away 4. And so A is 14. And then they just want us to do exactly that again, but they just give us some different values. So let's just check that equation again. A is 3B minus 2C. We're just subbing in B is minus 3, C is 4. So B is minus 3, 2, C is 4. And we work it out again. So 3 times minus 3 is minus 9. Minus 2 times 4 is 8. So minus 9, take away another 8, is going to give us minus 17. And then the third part of this question is what they usually do, which is then they say, okay, let's see if you can work backwards. So we have this equation. And now they tell us the big A is 11. So we've got 11 on this side. And we need to solve for the small b. Okay, minus 2 and C is 5. Okay, so it's one step more, but we can still do it. We're just going to work out 11 is equal to 3b minus 2 times 5 is 10. We want b by itself because that's what we're solving for. So let's take this 10 across. We were subtracting by 10. When we take it across, we do the opposite. So we add 10. Okay, so 11 and 10, so we get 21 is equal to 3b. We want b by itself, so we're going to take this 3 across. So we were saying 3 times b. That means we're going to divide on the other side. So we're going to say 21 divided by 3 is equal to b. And 21 divided by 3 is 7. So b is 7. Here are two triangles on a grid. Triangle B is an enlargement of triangle A. So that means this is A, and then triangle B is the enlargement. It is the bigger one. Write down the scale factor of the enlargement. So let's just get some measurements first. So here we've got this height is 2. It's 2 blocks. This height here is 1, 2, 3, 4, 5, 6. So we can see if I wanted to go from A to B, if I wanted to go from the small triangle to the larger triangle, I had to times it by 3. Okay, so I went from a height of 2 to a height of 6. That means I've times it by 3. That is my scale factor. So it's as simple as that. So my scale factor is 3. When you're working this one out, it didn't matter which side you chose. You could have worked with, say, for the base, you would have got the same thing. And then on the grid, mark with a cross the center of enlargement. So let's just get some space here. So how we find the center of enlargement is we have to draw lines through all the corners and see where the lines meet. So we draw lines to the corresponding corners. So here and here, we're going to draw a line through there. This bottom corner and that one. Again, excusing because I don't have a calculator. I don't have a ruler, which you guys would. And this top corner. And the center of enlargement is just the point where these ones all cross. So it is going to be where they all cross there. That is your center of enlargement. Next up, here is a parallelogram on a coordinate grid. On the grid, reflect the parallelogram in the line y equals x. So that is your first step. You're going to draw this line y equals x. So it's a pretty straightforward one. You will see this line a lot, but if you don't know what it looks like, when you draw x, it's equal to y. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2, and so on like that. So you have all these points where the x value and the y value are the same, and you just draw a line through them. And now they want you to imagine that this line is a mirror and we're reflecting the parallelogram onto this side. So it's fairly straightforward how we do it. We just reflect each point. So I'm going to say this corner here, it was a gap of 1. So on the side, it's going to be a gap of 1 to that corner. This corner here was 1.5, 1.5, and there it is. You just reflect the points over this mirror. This corner here, 1, almost. But yeah, it is 2. Okay, and then the final corner. This one is 1, 2.5. 2.5. And then we just redraw the parallelogram with these new points. And that is the reflection that they wanted. There are 32 cubes in a bag. 10 of the cubes are red. Let's just make that slightly smaller. "13 of the cubes are blue, and then the rest of the cubes are green." So this would be my first step, would just be, before I see what they're asking, let's just work out how many green ones there are. So green is 32 in total. We take away the 10 red, take away the 13 blue. So 32 take away 10 is 22. Take away another 10 is 12. Take away 3 is 9. So there are 9 green. As soon as you see this kind of thing, cubes in a bag, sweets in a bag, this is a probability question. So if you're struggling with that, that's what you need to look at, probability. Write down the probability that the cube is green. So all you do is, how many green cubes are there? There are 9 green cubes. How many are there in total? There are 32 in total. You just write it like that. What is the probability that the cube is not red? Okay, so if the cube is not red, that means it has to be blue or green. because the blue and the green cubes are not red. How many is that? That means there are 13 blue and 9 green. So 13 add 9 is 22. So there are 22 cubes out of the 32 that are not red. And finally, what is the probability that the cube is yellow? There are no yellow cubes, so it is a 0 probability. Question 12. In Company A, there are 98 full-time workers, 70 part-time workers. In Company B, 7/12 of the workers are full-time and the rest are part-time. Show that the ratio of full to part-time workers is the same for both companies. Okay, so this is a ratio question. As you can see, there's also some fractions in there. So if you're struggling with this one, that's the areas that you need to be looking at, ratio and fractions. So let's lay out these two companies and see what we can find. So in Company A, we want full-time workers to part-time workers. So I said there's 98 full-time workers and 70 part-time workers. But as soon as you see a ratio, you need to be thinking, can I simplify this? My trick for ratios when I'm simplifying, especially in a non-calculated paper, is I try to divide by 2 or 3 or 5. Those are my starting ones. So I can see these ones, I can divide both of these by 2. So I'm just going to start with that. Let's get it a little bit simpler. You have to divide both sides by the same number. So divide by 2 on both sides. 98 divided by 2 is 45. Add 4, so 49. 70 divided by 2 is 35. If you don't know that straight away, you're going to be working it out. 98 divided by 2. 2 goes into 9 4 times, remainder 1. 2 goes into 18 9 times. So if you don't know it straight away, work it out like that. Then we need to keep simplifying it. So 49 and 35. So I would run through my tests. Can I divide by 2? No. Can I divide by 3? No. Can I divide by 5? No. So then I start looking, is this one of the times tables? And these are in the 7 times table. So then we can divide both sides here by 7. And so our ratio is going to become 49 divided by 7 is 7. 35 divided by 7 is 5. And that is as far as I can go. I can't simplify this any further. So I'm going to leave that as my final ratio for Company A. Let's have a look at Company B. I've got my full-time workers to my part-time workers. They tell us that Company B, they have 7 out of the 12 workers are full-time. So that means there's 7 full-time. Let's just have a look. So that means there's 7 full-time. There's 12 in total. So 12 take away the 7 is going to give me 5 part-time. And so I can see my ratio, my part-time workers is 5, and that ratio is the same. So we have done what they've asked. We've shown that the ratio is the same for both companies. So this kind of question, you're going to get 1 mark for this one, because that's a pretty straightforward one. 2 marks for this one, because you have to write the ratio and you have to simplify it. Question 13, work out an estimate for the value of this. As soon as you see that word estimate, you know you've got to round at the start. You can't work it out and then round. So always round first. So 91, if it's a number like that, you're usually just trying to round it to the nearest 10. So 91, we could round that to 90. 1.73, generally when you're working with an estimate, you don't want to be working with decimals. So we're going to round it to the nearest whole number. So 1.73, I'm going to round it to 2. And then if we do our working out, it's really straightforward question. Then we go 90 times 2. is 180. That is our estimate. Part B, we're given that 3.14 times 1.6 is this. Find the value of this. So we know the answer is going to be some form of these numbers because we can see this one is pretty similar to that. This is pretty similar to that. The only difference is they want us to do some moving of the decimal. So let's just see what we got here. So to get from 3.14 to 314, we would have times that by 100. And to get from 1.6 to 0.16, we had to divide it by 10. And so what we can actually do, it feels strange, but what we can do is they have given us this answer here, this 5024. They want you to use that, 5.024, and they want you to just manipulate it. So we are just going to times it by 100 and divide it by 10, because that's really straightforward to do. So if we times it by 100, that means we move the decimal place 2. So it's going to be 502.4. And then we divide it by 10. That means we move the decimal place 1 space like that. And so we end up with 50.24. So you can see it's a strange question. It feels strange to do it like that, but they've given us the answer for a reason. And that's because they're actually just testing, can we move the decimal places? Question 14. Here's the list of ingredients for making 20 muffins. So we've got 400 grams of flour, 250 grams of sugar, and 150 grams of butter. Gary wants to make 50 muffins. How much sugar does he need? Okay, so the key thing here is all we're looking at is sugar. So we can ignore the other things. Just take them out so they're not adding to your confusion. And then my first step with a question like this is called, it's like ratios and proportions. So if you're struggling, that's what to look at. My first step for a question like this is always, how much do I need for one muffin? Okay, all we're looking at is the sugar here. So if I was going 20, if I want to get to 1, I have to divide it by 20. 20 divided by 20 is 1. I do the same thing to the sugar. 250 grams divided by 20 is going to give me how much I need for one muffin. So let's work that out first. 250, divided by 20. So can 20 go into 2? No. Can 20 go into 25? Yes, it goes in 1 time, remainder 5. Can 20 go into 50? Yes, it goes in 2 times. Remainder 10. Can 20 go into 10? No, it can't. So I'm going to put a decimal place. Add a 0. Can 20 go into 100? Yes, it can. It goes in there 5 times. And so we find for one muffin, we need 12.5 grams of sugar. And then it's pretty straightforward to go to 50 muffins. So then if I want to go to 50 muffins, I'm going to just times that by 50. And again, they are testing if we can multiply it with decimals. So let's set this up. And this is what we are doing. We are going 12.5 times 50. When I'm multiplying with decimals, I just take note of how many decimal places there were. So there was 1 decimal place, and that's what I need in my final answer. But when I set up my multiplication, I can just say 125 times 50, and I can just leave the decimal place. I don't have to worry about it when I'm actually working it out. So let's work this out. 0 times 5 is 0, 0 times 2 is 0, 0 times 1 is 0. So that one's, we don't need to worry about that. I move on to the next one. I'm working with this 5. Add a 0. 5 times 5 is 25. Then I'm going 5 times 2. So I add 2 zeros. 5 times 2 is 10. And then finally 5 times the 1. So I add 1, 2, 3 zeros. 5 times 1 is 5. And then I add them up. You don't have to do your multiplication in the same method as me. This is how I do it. But if you have another method, just make sure we get in the same answer. So that's 0, that's 5, that's 2, and that's 6. So 6250. Well, we've got to remember we have to add back that decimal place. So we had 1 decimal place when we started, so we need 1 decimal place when we finish. So we need 625 grams of sugar for 50 muffins. So like I say, with that one, what's really important is a proportion question. You always start by converting it to how many do I need for 1? And then it doesn't matter if your multiplication looked different to mine, just make sure your answer was the same. Question 15. Phil is buying a boat. The boat costs £18,000. Phil pays 20% of the cost as a deposit, and he pays the rest of the cost in 20 equal monthly payments. How much is each monthly payment? Okay, so they're testing our percentages here. And also our division. First of all, we are going to work out what is 20%. So I always work out, you don't have a calculator, make it easy on yourself. Work out 10% first. So 10% of 18,000. The reason we work this out first is because it's really easy. We just cancel one of the zeros. So it's 1,800. Then if I want 20%, I just double it. 20% of 1,800 or 18,000 is double that. So you can see I times that by 2. So I have to times this by 2. 1,800 times 2 is 3,600. So that is his initial deposit. That's what he paid off at the start. So then that means we've got to work out how much is left. So it started off, it was £18,000, and he paid off £3,600. So let's do the math on that one quick. So 18,000 take away 3,600. 0 take away 0 is 0, 0 take away 0 is 0, 0 take away 6 we can't do, so that's going to be 7. 10 take away 6 is 4, 7 take away 3 is 4, 1 take away nothing is 1. So that is how much he has to do, the remaining amounts he's going to pay off. And they tell us that he's going to pay that off over 20 equal monthly payments. So what that means is we've got to divide that by 20. So 1,400 or 14,400 divided by 20. Again, we don't have a calculator, so we are going to actually set this up properly and do it. So 20 goes into 1 0 times, 20 goes into 14 0 times, 20 goes into 144. Let's see, it's 20, 40, 60, 80, 100, 120, 140. So it goes in there 7 times. Remainder 4. 20 goes into 40 twice, and 20 goes into 0, 0. So £720 is how much he's going to pay each month. Question 16, here is triangle ABC, and they give us that these are the measurements in centimeters. The perimeter of this triangle is 62 centimeters. Work out this length AB. Okay, so this is a little bit of algebra here with these expressions, and then obviously area and perimeter too. So first thing we need to do is we need to set up an equation. So perimeter, the perimeter of a shape is if we add all the sides. Let's write that down, because what I would say to students generally is if you know what perimeter is, write it down because you could get a mark just for knowing that. So perimeter is add all sides. So this perimeter is going to look a little bit strange because it is going to be an algebraic expression, but it doesn't matter. So we've got here perimeter is going to be this side, x plus 5. Then this side, 2x minus 1. And this side, 2x plus 3. And they have told us that the perimeter is 62 centimeters. So we can actually, instead of putting that p, we can say 62. And what you can see now is this is actually just an algebraic equation. So we can simplify it. Let's add all the x's. Let's get x's on one side, numbers on the other side. On this side, we've got 62. Let's simplify this side a bit. So we're going to have x plus 2x plus 2x. That's going to be 1 plus 2 is 3, plus another 2 is 5. So 5x. Then let's look at the numbers. We've got 5 minus 1, add 3. So 5 take away 1 is 4, add 3 is 7. We want x all by itself. Let's take that 7 across. So we're going to go 62, take away the 7 when we take it across. 62 take away 7 is 55. We want x by itself, so let's take that 5 across. We were timesing by 5, we're going to divide by 5. So 55 divided by 5 is 11. So that means x is 11. Okay, and that is a lot of work, but we are not done yet. So we've got x is 11, and they want us then to work out the length of AB. So that is this one. So AB is 2x add 3, and we're just going to sub in our x value. So we know that x is 11. So AB is going to be 2 times 11 add 3. 2 times 11 is 22, add 3 is 25. And we are told it's centimeters. So make sure you include that centimeters so you can get your mark. So the length of AB is 25 centimeters. Question 17. 95 people bought raffle tickets. 18 of the 42 men who bought a raffle ticket won a prize. 23 of the women who bought a ticket won a prize. Use this information to complete the frequency table. Generally, what I've seen is students are quite good at frequency tables. You've just got to start filling what you can and we work out the missing numbers. So let's see. There's 95 people that bought raffle tickets. So that's our total here, 95. 18 out of the 42 men. So that tells us that there are 42 men in total. So we can put that here, 42 men. That means we can work out how many women there are. So there's 95 people in total. Take away the 42 men. 5 take away 2 is 3. 9 take away 4 is 5. It means we've got 53 women. Let's see what else we've got. So they say 18 of the men won a prize. Okay, that means we got to work out how many did not win a prize. So it's 42 men. Take away the 18 who won a prize. 2 take away 8 we can't do. 12 take away 8 is 4. 3 take away 1 is 2. So we have 24 men that did not win a prize. 23 of the women who bought a ticket won a prize. So this is 23 did win a prize. How many did not win? That is just going to be 53 women. Take away the 23 who won. 3 take away 3 is 0. 5 take away 3 is 3. 5 take away 2 is 3, sorry. So 30 women did not win. Question 18, increase 320 by 15%. So increase means we're going to add on to it. And we're going to add on to it 15%. As I said before, always work out 10% first. So 10% of 320. Again, really straightforward. You just cancel a 0. So it's 32. 5% is half of that. So half of 32 is 16. That's why we always work out the 10% first, because it's really easy to get anything else then. And then if I want 15%, I'm just going to add these. So 15% of 320 is just 10 and 5 added. So 32 and 16. That's going to give me 48. Okay, so that is my 15%. And they say increase 320 by that. So we're just going to go 320, add the 48. Which you can write it underneath each other and work it out. Or we can just say 320 plus 40 is 360 plus 8, so 368. Then we've got a decimal question with division. They're just trying to check that you know the tricks for this one. If you're dividing by two numbers, like this, you can multiply them by 10 or by 100. It doesn't matter what number, as long as you multiply them both by the same 10 or 100 or 1,000 to get rid of these decimals. So if I multiply this one by 100, I'm going to get 592. If I multiply this one by 100, I'm going to get 16. And I can work this out instead, and I will get the same answer. So that is what they are testing here. So in this case, I multiplied both of these numbers by 100, and then I do division because it's much easier that way. Okay, so 592 divided by 16. Let's work this one out now. So 16 into 5, it doesn't go. 16 into 59. Let's write our 16s table. So 16, 32, 48, 64. Okay, so how many times does 16 go into 59? It goes in there 1, 2, 3 times. Remainder 11. And I think we need some more times tables here. Okay, so don't be afraid to work out these times tables if you need. So let's see, 64 add 16 is 80. Add 16 is 96. 96 add 16 is 12. 112. That works nicely. So how many times does 16 go into 112? It's 1, 2, 3, 4, 5, 6, 7 times. And so our answer is 37. Question 20. Write 324 as a product of powers of its prime factors. Okay, so we need to draw a prime factor tree. 324, I usually just try to divide by 2 first. So divided by 2, it's going to be 150. Okay, let's just work it out. There's no shame in working it out like this. So divided by 2. 2 goes into 3 one time, remainder 1. 2 goes into 12 6 times. 2 goes into 4 twice. That is 162. And then I circle my prime number as I go. 162, I'm going to just divide it by 2 again. 2 goes into 1 0 times, 2 goes into 16 8 times, 2 goes into 2 1 time, so 81. And 81, I happen to know, is 9 times 9. And 9 breaks into 3 by 3. Okay, so these ones that are circled are all my prime factors. Then you can write your prime factors as this. So you would write 324 is 2 times 2 times 3, 3 times 3 times 3. That would be if they asked you for a product of a prime factors, but here they say product of the powers of prime factors. All that means is they just want you to simplify it a bit. So 324 is how many 2's are there? There's 2 2's. How many 3's are there? There's 4 3's. They want the powers there. Question 21 is a fractions question. So they want us to work out 2 2/3 and 1 3/5 and give our answer as a mixed number. So when you're working with fractions like this, the first step is always we're going to convert to improper fractions. So 2 2/3, how we convert to improper fractions is we always go the big number times the bottom number. So 2 times 3 is 6. Add the 2, so times there, and then we add the top number. So 2 times 3 is 6, add the 2 is 8, and the bottom number stays the same. So that's 8/3. We do the same for the next one. 1 3/5. So again, we go big number times the bottom number, add the top number. So 1 times 5 is 5, add 3 is 8, and the bottom stays the same. So that's our first step. Then the second step is we need to make the denominators, the bottom numbers, the same. So we need to find equivalent fractions. That's the next step. So 8/3 and 8/5. So we need to make it a number that is a multiple of 3 and 5. So that would be 15. So we're going to write both of these as something over 15. When you're converting to equivalent fractions, you always just see what did you do to the bottom, and you do exactly the same thing to the top. Okay, so we want both of these to be over 15. So in this first one, we would have gone 3 times 5 gives me 15. So we do the same to the top. So 8 times 5, which is 40 over 15. This one, 5 times 3 gives us 15. So at the top, we go 8 times 3. 8 times 3 is 24. And so we can see actually, instead of saying this 2 and 2 over 3, add 1 and 3/5, we can rewrite that and say that's the same as saying 40 over 15, add 24 over 15. When you're adding fractions, the base stays the same, and you add the top. So 40 add 24, so 64. And then they want us to give our answer as a mixed number, so we need to simplify this. So 64 divided by 15, it's 15, 30, 45, 60. So it goes in 4 times the remainder of 4, and the base always stays the same. So this is our final answer there. We can't simplify that any further. Okay, I'm just going to get some space, then we can look at the next one, which is a little bit easier than this. So the adding and subtracting fractions, those ones always end up being quite a lot of work. But then next we've got a division one, which is a lot easier. Okay, so question B here, they say 2/3 divided by 3/4. When we are dividing fractions, you can remember a lot of people say KFC. So let's write that down. So KFC. Okay, so you keep the first fraction exactly as it is, so 2 over 3. You flip the second fraction, so that's going to be 4 over 3. You flip it over instead of 3 over 4. And then you change the sign. So instead of divide here, we are going to be timesing. So let's just get a different color. Instead of divide, we're going to change it to times. And so we're going to actually just work this out. So we're just going to say 2 times 4 is 8. 3 times 3 is 9. And that is our final answer. So you can see division is really straightforward in comparison. You just got to remember it's always keep the first. Okay, so keep the first fraction. Flip the second. And then C is change the sign. So division becomes multiply. Okay, then we've got this one, they're testing our knowledge of exponents here. So work out the value of 5 to the negative 3 times 5 to the 7. So these ones we need to know our index laws. And what we're going to do is we're going to work with the top first. So let's just write this out. 5 to the negative 3 times 5 to the 7 over 5. Okay, so if we look at the top first, with our index laws, they tell us that if we are timesing two numbers like this, the bases are the same, we can just add those exponents. So that is our first index law. So we can just say 5 minus 3 add 7. And the base, we haven't done anything yet. If we simplify that, minus 3 add 7 is 4. So 5 to the 4 over 5. This 5, it doesn't have a 1, but it is 5 to the 1. And then next, the next index law we're going to use is when we are dividing numbers like these, we subtract. So we can say this part here is the same as saying 5 to the 4, take away that 1 at the bottom, which is 5 to the power of 3. And if you want the value then, that is the same as saying 5 times 5 times 5, which is 125. Question 23, Tracy writes down three numbers A, B, and C, and then we've got these two ratios. Find out the ratio of A to B to C. So for a question like this is actually testing equivalent ratios, which is basically the same as fractions. So what we want to do is we want to try get these A's in these ratios the same, because then we can just write all the numbers after each other. And so what we're going to do is we're going to take the two ratios. So we first got this A to the B is 3 to the 5. A to C is 4 to 7. And we want to get these, the A, we want to get them to be the same number. So 3 and 4, we could use a multiple of that. So we can say, let's try convert both of these to 12. So let's say we want to get it to 12. So A is going to be 12 for both of these ratios. And ratios work exactly the same as fractions. Whatever you do to the one side, you do to the other side. So this side, 3 times 4 would give me 12. I have to do the same here. So 5 times 4 gives me 20. On this second one, let's just get a different color here. Okay, so what do I times 4 by to get 12? So 4 times 3 gives me 12. So on this side, 7 times 3 gives me 21. And then we can see A is the same here as it is here. So now we can just write these ratios next to each other. So A to B to C is going to be A is 12, B is 20, and C is 21. Part B. Jamie writes down three numbers, D, E, and F. D is equal to 2E, F is equal to 3D. Find the ratio of E, D, F. For this one, what I'm going to say is, I'm going to say, let E equal 1. Okay, because if E is 1, then D is equal to 2E, which means D is equal to 2 times 1. So D is 2. And F is equal to 3D. So F is equal to 3 times that 2. So F is 6. So we can say then, E is 1, D is 2, and F is 6. So that is the ratio for those ones. You could have written any number for E here. You could have said let E equals 2, let E equals 4, let E equal 5. It doesn't matter. In the end, you're going to simplify your ratio and you'll always get this one. It should work out the same no matter what number you use. The diagram shows a cuboid. The cuboid has a height of 3 meters. Okay, so they show us that here. And the volume of the cuboid is 21 meters cubed. The pressure on the floor due to the cuboid is 25 newtons per meter square. Work out the force. Okay, so this might be one that you don't work with a lot, but you can see they've given us a formula here to use. We have the pressure. What we need is this area. That's what we need to work out so that we can work out the force. So they give us the volume. So the volume of any 3D shape is always the area of the base times the height. In this case, they tell us the volume is 21. We don't know the area, but we do know that the height of this is 3 meters. If I want to get the area by itself, I'm going to take this 3 across. I was timesing by 3, I'm going to divide by 3. So 21 divided by 3 is going to give me 7 meters squared. So that is my area. Okay, and then if we look at that formula again, I'm just going to write it up here. So they tell us pressure is force over area. We want force all by itself because that's what we're trying to work out. We're trying to work out what is the force. Okay, so let's take this area across. I was dividing by area, and when I take it across, I'm going to times. So we can say pressure times area will give me the force. And then let's sub in our values here. So they tell us the pressure. Let's see what that value is. The pressure is 25 newtons per meter squared. Times the area, which we've just worked out to be 7. That is correct. Yeah, 25 times 7. If we work that out quickly, 7 times 5 is 35. 7 times 2 is 14. It's 5, 7, so 175. So it is 175 newtons is our force. "25. In a bag, there are counters. The counters are all either red or blue or yellow. We have the ratio here. So we've got red to blue to yellow is in this ratio, 4 to 5 to 8. The number of yellow counters is 24 more than the blue counters. Work out the total number of counters in the bag. Okay, so this one is kind of a strange one to wrap your head around. What they're telling us is that the number of yellow counters is 24 more than the blue. So the difference between these is 24 counters. Okay, so we can see we've got 8 yellow counters. We take away the 5 blue counters. So there's a difference of 3 in this ratio. So 3 parts is equal to 24. The 24 is equal to 3 parts in this ratio. We want it to be just one part. So let's work out what 1 part is. So that means we're going to divide it by 3. 24 divided by 3 is 8. So 1 part is 8, and then we can work out this ratio. If 1 part is 8, then 4 parts is 4 times 8, which is 32. The 5 parts is 5 times 8, which is 40. 8 parts is 8 times 8, which is 64. So that is the number of counters that we have. So we've got 32 red ones, 40 blue ones, and 64 yellow. They want us to work out the total. So the total is 32, add 40. So that is 72, add the 64. That is 6, and 7 and 6 is 13. So in total, we've got 136 counters. Question 26, ABC is a triangle. AEC, so AEC, and ADB are straight lines, okay? ED is parallel to CB, we can see that here. And then angle CED is 122, we can see they've given us that, and angle ABC is 59. Work out the size of angle CAB, so CAB. So they want, what is this? Yeah. You must give a reason for each stage of your working. Okay, so usually with an angle question like this, I would just try fill in as many things as I can see to start with. So they have given us, let's have a look. Okay, so first what I would do here is I'm going to work out angles on a straight line here. I'm going to work out what this value is in here. Okay, so they say give a reason for each stage of working. So let's label that as y, just so we know what we're working with. So let's say y is equal to 180, take away the 122. 180, take away 122. I have to borrow. That's 8. 7 take away 2 is 5. 1 take away 1 is 0. Okay, so that's going to be 58 degrees. And the reason is angles on a straight line add up to 180 degrees. Okay, so we know that that angle there is 58. The next thing we can do is we could actually get this angle here. So let's call that, so this was y, and then this one, let's call this one z in there. And angle z is going to be, this is the same as this. Reason being, we've actually got corresponding angles here. So we can see we've got this F shape here. Okay, so we can say here then Z. It's okay to use like X and Z. Just make sure you label on the diagram so they can see what you're talking about. So Z is 59 degrees. The reason being corresponding angles are equal. And when you use corresponding angles, we have to say why we can use it is because of the parallel lines. So we can say ED is parallel to CB. That's why we can say that. Okay, and then if we look at this triangle at the top there now, if we fill in Z, we said that's 59. We can actually work out what X is because we've got this triangle AED there. Looks like this. We have got that this, we're trying to work out, this one is 58, this one is 59. And so we can use angles in a triangle. So we can say X is equal to 180, take away 58, take away 59. Because angles in a triangle add up to 180 degrees. And then if we work this out, let's see, 180, take away 58. Got a borrow here. 10 take away 8 is 2. 7 take away 5 is 2. 1 take away nothing is 1. 122 take away 59. Again, we got a borrow. So 12 take away 9 is 3. 1 take away 5 we can't do. 11 take away 5 is 6. So 63. And that means X is 63 degrees. And question 27 is a vector question. So work out 3a plus b as a column vector. All we have to do is wherever there's a, we put in this vector. Wherever there's b, we put in this vector. So 3a means 3 times this plus b minus 1 to 5. Okay, we just work it out. So 3 times 3, and this one here is going to be 9. 3 times 2 is 6. Adding this vector here. And so we're going to get 9 minus 1 is 8. 6 add 5 is 11. And that is our final column vector there. I really hope this video helps. Please let me know if you have any questions or if you'd like me to look at any different papers. You're always welcome to comment, and thank you for watching.